Hi, this is Sinclair, a podcast detailing the works and discoveries made by David Sinclair's lab group at Harvard Medical School. David's group is working in an exciting new field, anti-aging. This podcast will serve to spread the word of what David's group has already uncovered about anti-aging and talk about new discoveries that are made in the field. In this episode, we'll be taking a step back to review all that we've learned in the past 4 episodes. This episode will review the answers to questions like, why do we age? Can we stop aging? And what can I do to slow down my own aging? This episode will also try to tackle questions like, at what age should I start implementing the 4 pillars to anti-aging in my life? When should I start implementing the 5th pillar, anti-aging molecules? And is there any risk to taking anti-aging molecules? In doing so, I hope this can serve as a one-stop shop for anti-aging practices, giving you the tools and knowledge needed to determine what you should be doing to slow your aging at this very moment, and what you can do in the future to slow your own aging. So without further ado, let's jump right into the review, starting with the first question. Why do we age? Well, as David explained in episode 2, there are numerous theories that have been proposed to explain why we age. And for the most part, these theories have addressed the physical mechanisms that drive aging, but have failed to address the fundamental question of why biological entities, like ourselves, even age at all. Some of these past theories include the DNA mutations theory, which claims that aging is due to the accumulation of DNA mutations in our cells over time as we age, the free radical theory of aging, which claims that aging is the result of damage caused by free radicals in the environment to our cells, and the disposable soma hypothesis, which claims that due to limited resources, species evolve to age and die off in order to make room for the next generation. These theories are akin to saying the reason a boat is sinking is because there's a hole in it. Sure, technically the boat is sinking because there's a hole in it, but what caused the hole in the first place? And is there a way we could have prevented the hole from forming? In a similar manner, these theories behind why we age explain the mechanisms that occur as we age. But why do these mechanisms even cause aging in the first place? What's driving our bodies to be unable to repair itself from DNA mutations or damage caused by free radicals in the first place? Or, in other words, what's the fundamental force that's driving us to age? This fundamental question is what David's information theory of aging attempts to address. His theory supersedes all the downstream mechanisms that cause aging and ultimately says aging is driven by one singular reason: a loss of information. This loss of information takes a real physical form in our bodies. It's a loss of epigenetic information. And if you haven't heard of the term epigenetics, fear not, as you're not alone. The term epigenetics was only coined in the last 80 years, which is relatively young in the world of science. But as we learn more and more about it, we've come to realize that epigenetics plays a crucial role in both our body's health and our DNA's very existence. In scientific terms, epigenetics are post-translational modifications on our DNA and histones, which convey their conformation, which in turn determines their expression level. In layman's terms, epigenetics are little attachments to our DNA that determines whether a gene is turned on or off. These attachments can be taken off or put on with relative ease, and that's what allows our cells to change in response to environmental factors. You might have heard things like, too much stress can change your body at a cellular level, or meditation can literally change your DNA, and thought, well, how does that work? Epigenetics is how. They are the reason we are able to start as just one tiny cell as an embryo and grow into a full, living, breathing creature. Different epigenetic profiles are what makes kidney cells different from heart cells, different from skin cells. Or you might have heard that every cell in your body contains your entire genome and thought, well, how is that possible? If if they all have the entire genome, or all of your DNA, how are they able to turn into different cells? One word: epigenetics. And this, as David's theory states, is the information we lose over time. Our genes, actual genetic information, is relatively stable, but our epigenome, or all of the epigenetic modifications in our body, is vastly changed as we age. And while there are a few other elements at play, this loss of epigenetic information is what David's theory proposes is the main driver of aging. If you want to learn more about why we age, go give episode 2 a listen, as I dive a bit deeper into the previous theories that tried to explain aging and David's new information theory of aging. So the next question is, can we slow this loss of epigenetic information? How about stop it, or even reverse it? Well, we can certainly slow it, and current research suggests that in the future we will probably be able to stop it and even reverse it altogether after it's occurred. But the big point here is that right now, in the year of 2021, we possess definitive knowledge on how to slow aging. Not your actual number age, 35 or 60, but your biological age, or how old your body looks at a cellular level when compared to benchmarks of natural ages. So, how do you slow aging? Well, you've actually probably heard about the basics to anti-aging already. They're tried and true, age-old adages on how to live a long and healthy life. The most important of which I like to call the 4 pillars of anti-aging. The 4 pillars are food, exercise, stress, and sleep. Now, there's already plenty of information out there surrounding the 4 pillars of anti-aging. So I'll just briefly touch on each of the 4 pillars to give you an idea about how you can get anti-aging effects out of them. And luckily, satisfying all 4 really isn't that hard. For food, eat a well-balanced diet of whole foods that is low in carbs and sugars. Less is more. Not starvation, not malnutrition, just less. Eating less is a surefire way to live longer. Using practices like intermittent fasting or calorie restriction are very beneficial. But most importantly, listen to your body. As Luigi Carnado put it, I strive to never feel full, and he lived to be nearly 100 in the 15th century. For exercise, try to get at least 30 minutes of cardio a day. Take a walk or ride a bike. Stretch a little. Use your body every day. Think of exercise like brushing your teeth, but for your muscles, bones, and joints. If you don't have a gym membership or access to a gym, there are plenty of body weight workouts, such as standing squats, push-ups, and crunches that you can do every day. For stress, don't sweat the small stuff. This applies to the first 2 pillars as well. We all have bad days, but at the end of each day, most of us get to feel the sunlight on our skin, smell the flowers, and listen to the sounds of the world. Be grateful for what you have because it won't last forever. Meditate. And for sleep, try to get 7 to 8 hours a day. Sleep is crucial to both our body's health and our mental health. If you are having trouble sleeping, look back at the first 3 pillars and see if making an adjustment in one of those can help you rest better. Are you eating properly? How much sugar are you consuming? Are you getting enough exercise? Are you stressing out over something that, in the grand scheme of things, doesn't really matter? And that's about it. Like many great things, the 4 pillars of anti-aging are pretty straightforward in theory, but in practice, they are very difficult to master, as the dessert table makes all too obvious. But let it be known that neglecting any of the 4 pillars will result in a diminished lifespan and vitality. A addressing all 4 of these pillars to their fullest, on average, will certainly get you into your 80s, if not 90s. But what about going the extra mile? Is there another way where we can slow our aging that will push the upper limit of our lifespans past 100? How about making those last 20 years more enjoyable, filling them with more energy, more mental clarity, and stronger bodies? Well, we've recently discovered a cohort of molecules that look like they do just that. These anti-aging molecules make up what I like to call the 5th pillar of anti-aging. And while the jury certainly isn't in on their effectiveness in humans, animal studies have shown an increase in lifespan by as much as 40%. A similar effect in humans would change the average lifespan in the United States from 78 to 110. And while the research is still underway to determine how well or even if these anti-aging molecules will work in humans, we do know 2 things for certain. The first of which David pointed out in episode 4. We all know what is going to happen if we don't do anything at all. We also know that they're safe. The molecules that make up the 5th pillar have been studied in humans at up to 5 times the amount needed to get the anti-aging effects from them. So what are these anti-aging molecules? Well, the 5th pillar is made up of 3 key components: a daily multivitamin, an antioxidant, resveratrol, and an NAD booster, specifically NR or NMN. In later videos, I'll be diving deeper into both resveratrol and NAD boosters to look at how they work and some results that have demonstrated their anti-aging benefits in both animal and cell models. And as far as dosages go, I started my parents off with 300 milligrams of an NAD booster and 500 milligrams of resveratrol daily, with the expectation that they'd work their way up to taking 1 gram of an NAD booster and 1 gram of resveratrol, the amount David Sinclair himself takes daily. So when should one start taking the 5th pillar to slow down aging? Well, the first one, a multivitamin, is something almost every adult over the age of 18 should be taking. The next 2, resveratrol and an NAD booster, are probably something you don't need to start taking until later in life, say between 30 or 40 years old. It's hard to pin down the exact age that you should start taking these supplements, as the research to answer those very questions is either underway as we speak or hasn't yet begun. I think it's safe to say, though, that if you are 40 years or older, you should almost certainly be taking the 5th pillar regimen on a daily basis to slow your own aging. And this brings us to the final question I posed at the beginning of this video. What about the safety of taking these molecules? Are there any potential serious side effects to taking resveratrol? How about an NAD booster? I'll be the first to say that I am not a doctor, and as such, if you have any serious concerns, you should speak with your doctor to determine what the risk may be for you. But if you're just the average Joe with no underlying medical conditions and not taking any other prescription medicines, I can tell you what the research on the safety of these drugs has found, because luckily, that research has already been done. So let's start with the first one, resveratrol. In a report prepared for the National Institute of Environmental Health Services in 2002, titled Trans Resveratrol, Review of Toxic Literature, it was found that no adverse effects of resveratrol have been reported. The report lays out examples of several animal and cell model experiments done to determine what the upper toxicity limits of resveratrol are. The studies found that the no observed adverse effect level was 300 milligrams per kilogram per day in mice. The equivalent dosage in a human would be 20 grams of resveratrol per day. Another report prepared for the National Library of Medicine found that there were no adverse side effects in humans using resveratrol dosages as high as 5 grams a day. And if you've been following along with the dosages I've laid out, the amount of resveratrol needed to get its anti-aging benefits, 300 milligrams to 1 gram a day, you'll see that these are well within the acceptable safety range for the molecule. But what about NAD boosters like NR or NNM? In a report titled Possible Adverse Effects of High-Dose Nicotinamide Mechanism and Safety Assessment, it laid out several studies that showed that taking as much as 3 grams per day of an NAD booster had no adverse side effects in humans. It also outlined a study that found that taking 6 grams per day of an NAD booster resulted in minor side effects such as headaches or nausea, but they quickly ended after termination of supplementation. And just like with resveratrol, the amounts of NAD boosters needed to achieve anti-aging effects are within the 300 milligram to 1 gram range, well within the acceptable safety limits for human consumption. And with that, we've touched on all the questions that were laid out at the beginning of this video. Hopefully you've learned a little bit about why we age, how you can slow your own aging, when you should start engaging in some of these practices, and how safe they are. In the next episode, we'll be taking a look at some of the ethical dilemmas that arise when you extrapolate out the effects that anti-aging practices could have on both our species and the planet. If you're interested in learning more about anti-aging and would like to support the channel, consider buying David's book Lifespan via the link in the description. If you're also interested in taking any of the anti-aging molecules outlined in the 5th pillar of anti-aging, please consider using the links in the description to purchase them, as it helps to support the channel. And as always, please like, subscribe, or follow the channel on any of the platforms in the description if you'd like to learn more about anti-aging or support the making of this podcast. Thanks for listening, and until next time.